This week, we study a design using a pattern called Model View Controller and a few other patterns that are design patterns. We will do it through a drawing program that we will start designing and constructing. The Model View Controller pattern is unlike any of the patterns that we have studied in this course up until now. This is what is called an architectural pattern. The patterns that we have studied so far, like singleton or adapter or facade, they are all design patterns. Then what is the difference between an architectural pattern and a design pattern? The Model View Controller, MVC for short, is an example of an architectural pattern, as we just mentioned. In an architectural pattern, we have a system that we want to design using subsystems. So the division of the system is in the MVC pattern consists of three modules, three subsystems: model, view, and controller. The model itself might consist of multiple classes, so would controller and view. In fact, there could be containing many classes, especially the controller and view. So there could be a large number of classes in each of these subsystems. If you contrast this with a design pattern solves a small part of a problem. For example, how do you make a class a singleton? Or how do you use an existing class as an adaptee to create an adapter that would satisfy a certain interface? So the scope of design patterns is pretty limited to a small part of a piece of software. It consists of a few classes and a few interfaces. Whereas in an architectural pattern, we are thinking in terms of a whole system, a large system, and a broad division or a broad architecture of that system. So in the MVC pattern, as we just saw, we are saying that the system will consist of three parts: a model, a view, and a controller. So what is the role of each of these three subsystems? The model is going to contain data. The view provides multiple views, possibly, of the data. And the controller receives user input. And that input could modify the model, which could be displayed by the multiple views. So we have a user who issues commands. Those commands are received by the controller, and the controller manipulates the model, adding data, modifying data, deleting data, and so on. And as this data changes, the view observes those changes and displays the changes on the screen. And that is this interaction here, the view showing the data to the actor. As you issue commands, some of these commands need not really manipulate the model. They could directly affect the view. For example, if you are scrolling, you're not really changing the data. You're simply seeing different parts of a document or different parts of the data. So that could be a simple manipulation of the view or maybe not a simple manipulation, it could be a complicated manipulation. But anyway, it is a manipulation of the view by the controller. So you see an arc from the controller to the view itself. So if you think about this, the model is observed by the view. So the model could be thought of as an observable in the observer pattern. So the model could extend property change support. Then this is a class adapter, or the model could have property change support as a field, in which case it would be an object adapter. And as you modify the data, you would probably call a method such as update view, which could fire a property change, and the view could then extract information from the model. The view is a listener. As the model changes, this method, property change, gets called as the model issues the fire property change method call, and the event information is passed here, and the view could have a strategy to pull or get information pushed from the model. So in the MVC architecture, all data display is done through the view. The model holds the data, and the controller handles user input. A broad division of responsibilities like this makes MVC provide cohesive modules. For example, the role of the model subsystem is to simply store the data and search it or add, remove, etc. Whereas the controller is only focused on user input, and the view is only focused on presentation issues. So there is a lot of cohesion. And this gives you flexibility in modifying the different parts of the systems. And we use well-known paradigms to connect these things, so there is low coupling. And such an approach is used in distributed systems. For example, if you're interacting with an online store, the database that contains the products that the store sells is stored at some server, and there are engines that would pull this information and send it over the internet and show you on a browser. The browser takes your input and sends those commands to the server. So the server has a module that would be responsive to these commands, and then either manipulate the view directly or pull information from the database and show them through your browser.